All right, so I'm just going to go over a little bit about how the structure works with our modular spaces and just some of the fundamentals to help you understand the principles behind it. First thing that we'll look at is we have our steel portal frame. So this is essentially the skeleton of the whole space. Running along the bottom we have these 150 by 100 RHH, which is rectangular hollow section steel. And these replace the need to use anything overly heavy like a universal beam or a PFC beam. Those are quite heavy and it's what you'd usually use in a traditional build, but because we want to make these as light as possible for transport, we use RHS, which does just as good a job as any of those other beams like UBs or PFCs. So these run along the whole perimeter of the building. This is a granny flat model, so it comprises two of these units. So we've got a 6 by 3.5 meter here, and then adjacent to that we have another 6 by 3.5 meter pod. And so we build them on site in place together, but these two get separated for transport. And they go on either two separate trucks, or if we have a big enough truck we can put them both on one truck, but they'll be long ways, they won't be assembled like this. Going on from our RHS along the bottom, so you'll see that's all around the perimeter, all along the perimeter here. On each corner we have our vertical structural components, so these are square hollow section or SHS, 89 by 89 mil. So we have these in all four corners, and then these get connected with a beam along the tops. So that forms the, I guess, the skeleton for the structure. Once that's all welded together, that becomes like a very rigid structure. We do all of our infill. So for the floor infill we use, for our floor joists, we've got a 150 C-purlin. We put these every 450 mils, and that can be self-sustaining on one span. So no intermediate supports required. So when we actually install these on site, we only need to put piers along the outside edges. Moving up from the floor structure, we have our wall infill panels. So once again, we have steel. The reason we're using steel is because they're lightweight, and it also helps in keeping that weight down when transporting. These are all designed and engineered to be pre-braced. So if you have a look at the diagonal members and the frames, those all help with the bracing and to keep the whole thing rigid for the life of the product, but also for transportation. Going up from the wall panels, we then have our roof and ceiling panels. So the roof panels are all pre-manufactured and designed and engineered in the factory. We have a drop ceiling here, and that's for two things. It's where we put our insulation in the little cavity there, but it also allows us to run all of our services. We can't run services through the corners because we've got the steel posts. So we make a cavity between the ceiling and the roof panel to run water and power. For that, all of our openings are pre-done to match the design of the windows, and all engineered to make them to be able to withstand all the wind loads. It depends on the area that you're in. The next step that we have from here is we will put ply on the outside of this, because this particular model is the COLORBOND end seam, and that needs a bit of a backing to hold the product nice and strong and firm. So the boys will be doing that next. Also, we put some hoop iron strapping on the top that helps lock the whole roof in to the walls and stops any rotation. But yeah, that's all the structural components for our system and the way we build. This is pretty much the same for every build. We just do it smaller, bigger, more or less.